Okay, welcome back, everyone. Let's get started to our second session, which is experience and knowledge sharing workshop. So this session will build on the training that we had before and shifts to the focus to real world application. We invited our project partners who will share their first-hand experiences with BGPWatch platform. So before getting started, let me give a brief introduction to our partners from 4 organizations. The first one will be from KSTI. Changjin Park will give the presentation about their experience with BGPWatch from their perspective. And the second one will from Nepal Unrun, Chairman Loshan and the Executive Director Rajan will share their experience. Also, the CTO from Learn Sri Lanka, Dr. Asida, he will give their perspectives. The last part will be given by Pakistan Unrun. Unfortunately, they couldn't make it on set, so there will be remote presentations. So let's get started. Let's welcome Changjin Park from Korea. Let me have his slides here. Okay, that's a.
Okay, good afternoon. It's my pleasure to see all of you at the APAN61 and BGPWatch section. My name is Chanji Park, working on ClearNet and Kisti, and I'm responsible for operating ClearNet backbone and networks. Okay, let's start. Yeah, people sharing our experience. I want to introduce our network, ClearNet. What is ClearNet and about ClearNet? ClearNet is the Korea Research Environment Open Network. ClearNet is our domestic backbone, and ClearNet 2 is our international backbone. Our main role is to support the scientific community by providing high-performance network. 1988, we started with the Korean National Science and Research Network. And 2005, as a core member of Gloriad project, we started international network service. And 2023, we built a 600 Gbps international backbone with 6 gigapops. Daejeon, Hong Kong, Singapore in Asia, and Chicago, Seattle in North America, and Amsterdam in Europe. And at the same years, we built the 6 Tbps domestic backbone with 18 regional gigapops, Seoul, Daejeon, and so on. Actually, we support about 20 R&E organizations, including government, research institute, and university lab, and library, and so on. And we provide the NOC and some kind of the network service. Okay, this is map of ClearNet 2, our international backbone. At the center of this map, there was Daejeon in Korea. From the Daejeon, there are 600 gigabit rings around all over the world. As you see in this map, first one is the Daejeon to Chicago link. And second is Daejeon to Seattle link, and third link is the Chicago and Amsterdam link. And in Asia, there are some links from Daejeon to Hong Kong, and Daejeon to Singapore, and Singapore to Amsterdam links. Every 3 years, we upgrade our network backbone. This year is that year. We are preparing upgrade our backbone, and now is the negotiation stage. The major change in our upgrade is that first one is the Chicago and Daejeon link. It will be changed from the 100 gigabit ring to 400 gigabit rings. And second rings is about the Singapore and Amsterdam link. As you know, the submarine cable between Amsterdam and Singapore has suffered from the long and frequently outage. So we are considering to retire this submarine cable links. And last one is about the Chicago and yeah, Chicago and Amsterdam links. Actually, in our RFP, we recast the 100 gigabit rings, but in negotiation, we are encouraging our vendor to give more bandwidth. Yeah, we hope to get more. So after upgrade, we will get 900 gigabit more bandwidth in around the world. Yeah, this is map of ClearNet domestic backbone. At the center of this slide, there are Daejeon. Daejeon is the city located in Kisti. From Daejeon to Seoul, we have the 1.2 terabps link. Yeah, it is 600 coupled 600 gigabit links. And from the Daejeon and Seoul, the 16 gigapops is connected more than 200 gigabit rings. Yeah, and in domestic backbone, we also going on upgrade, and so network backbone will be changed from the 6 terabps link to 7 terabps link using the 800 giga lambda technique. And second thing is about the building 1.2 terabps index backbone. Index backbone is the national data exchange backbone. It's really similar with internet exchange, but it's some different. It's just that data exchange node. We are building it on the Seoul and Daejeon and Busan. Seoul node is for the connecting the cloud provider, and Daejeon node is for the connecting to our user, and Busan is for the connecting our international partner networks. Yeah. And third thing is the super silent to infra. It is the 80 kilometers long dark fiber infra near the Kisti, connecting 11 research institute. Yeah, it will support the QKD technique test bed and the time frequency transfer test bed and data sensing test bed. It will be used there. Yeah, because the why I introduce our network backbone, I want to tell you we have the very big network. Because that we need to operate the big network, we needed many monitoring system and operating system. We had to monitor the network fault to respond immediately to the fault, and we had to monitor traffic, how much traffic has used in our backbone and how much spare bandwidth we have. We have to know that. And we also have to monitor flow and routing, security, and so on. We have many systems to operate, to monitor and operating. Yeah. First one is a CNI MCP. It's just the optical layer EMS system. And we operate NMS for network layer. And third thing is APA. It is the network routing monitoring system. Yeah. And there are we have another monitoring system. But each only can monitor internal network in ClearNet. We cannot get visibility into external network. To get the visibility into to know the external network condition, we have to cooperate with the external network partner. That's why I needed the BGP watch, like the like the system, which is already collaborate with many RNA networks. Yeah. Oh. Yeah, this is first experience. Actually, people session. Yeah, presenter described the many function about the BGP watch. So it's please understand it's just our experience how to use BGP watch in ClearNet. Yeah, it's small things. Yeah, first experience is the RPKI implementation with BGP Watch. I used the BGP Watch when we implement the BGP RPKI. Actually, it was the first case of the RPKI implementation in Korea. And to last year, ClearNet create ROAs, and for ClearNet 2. 192 ROAs for AS1237 and 27 ROAs for AS17579. And the filtering, invalid prefix filtering has applied using validator. And we don't have IP version 6 ROAs because KRNIC don't support IP version 6 ROA until now. Yeah, the image in the center is maybe familiar with you. It was I captured it on the dashboard in our AS. Left one is the 17579, and right one is the 1273. In the progress of the RPKI implementation, we had to view all prefix at glance to verify the prefix which is invalid and which prefix is valid and which prefix is not found. To make sure not missing our prefix. Yeah, it was very helpful. And sometimes after deployment, sometimes I open a check to make sure there are not changing. Yeah, so sometimes I in this slide I got some invalid prefix, so I asked to our NOC to fix it. Yeah, it was very helpful for us. And second experience was peer monitoring. Actually, we can see the prefix with the advertising prefix and receiving prefix on the router, but on the router we can see the only one peer one by one. But in the BGP Watch, we can see all our peers at a glance. That was very helpful. So this is 17579 is our international network AES, and we are connected with the Cogent and SGGS. Cogent is the ISP internet provider in US, and SGGS is the internet provider in Singapore. It has the same relation, provider and provider, and we have the same policy to the same relation. But we can find different export. Oh, so we needed to check why. I want to know the why. But actually, it was some incorrect information in BGP Watch. Actually, it was the same, but the number was not correct, exactly correct. Yeah, not correct. Yeah. So if I think it would be better if when I clicking the number of this, if I can see the details of the prefix, we can check which one is incorrect. And this one also the incorrect. we don't have a pairing with this AS, but the BGPWatch shows the pairing. It was incorrect information for us. I think this function is very helpful for us. I want to get this is in ClearNet, but I think it should be fixed. Should be fixed. Thank you. But it was also helpful because we have a chance to check our policy and our prefix to announce and the prefix we are getting. It was very helpful event for us. Third thing is the forwarding and reverse routing path. I think it is the most common case and most common case use case for all of us. Actually, a symmetric routing path is common on internet, but a symmetric path can cause performance degradation. To improve performance, we make the symmetric path. Our user announces us the performance degradation between the Japan and ClearNet. So we investigate the why. We found that the forwarding path was between ClearNet and APAN-JP via ClearNet 2 and 10, but reverse path was the from APAN-JP to ClearNet only via ClearNet 2. It was the symmetric path. In this progress, we used the to find a forwarding path, we used the trace route on our router. It was very easy and common. But as you know, to find the reverse path, we have to use some other way, like the looking glass. We used to use this way, but as you know, to use this looking glass, every the network operator should operate looking glass, but it's not. Actually, in Korea, our commercial network don't operate looking glass, and it's hard to find the where looking glass is. It's very hard. It's hard to searching. And second way, I think it was using the BGPWatch. It was very easy. I just went to the forward path and checked the APAN-JP and our IP address, source IP address, and we can find the reverse path from APAN-JP to ClearNet. So after that, we fixed the forwarding path without 10. I think it was the right path without 10. So it was our third experience. I think it's last our experience. Subscription of the BGP hijacking. Actually, I subscribe to the alert sent by BGPWatch. This is the email I've got. But too many emails and too much information was sent it by me. Oh, that was my fault. Really my fault. Because I thought this command was only AS1273 and 17579, but it was range. So I described it more than 15,000 AS. So every day I got more than 50 emails. So why? That's too many, and that was big. Yes. that makes me hard to read my email. So today I asked to him, how can I clear my ASF? But it was not. I have to remove one by one. 50,000 ASF. It will be very hard things to me. But I think this is my fault. Make some good example. Yeah, we can find book, and I can get my email, and in my email I can check. We can get a if when our AS and our prefix hijacked to other attacker, we can know who attack our yeah AS and prefix. Oh, I think it was very good function. So I want to share this experience. Yeah. So yeah. For using this function, I thought first one is the subscribe only our AS, and then I thought it could be not enough. So I thought my upstream AS should be added. Yeah, it right? I think it could be so helpful. Yeah. Yeah, because the way I think this way, it is the issue in Korea actually. Last year I met the LG Telecom operator. LG Telecom is the internet service provider in Korea. He knows the BGPWatch, and he mentioned this function subscription because in Korea there are no alert system and IP monitoring system. And he said, this is very helpful. He mentioned and introduced this system to me. So I said, oh, I'm a partner of YouTube partner. Yeah, yeah, he's shocked. And in this year, the KRNIC, Korea Internet Center, interested in the monitoring and IP system, IP routing systems. So they got funded from the government. It is over $2 million. Yeah, they will make like this system. Yeah, and for the our ecosystem eco network system in Korea. Yeah, I think. Yeah, yeah. So I think this experience and this system could be the reference that for the Korean ecosystem. I think I was the I'm one of the member of them. So yeah, so I can suggest them. Yeah, 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 yeah. That's all. Yeah, thanks for listening. Yeah.
I think maybe our engineer 自动培 he can help with the deleting the AS and
Okay.
So our next speaker is Lao Shan. Oh, Ruan, it's your turn. He will share the perspectives from Pakistan. From Nepal. I'm sorry. From Nepal.
Thank you. Thank you for these opportunities, and thank you for the team for these opportunities to participate and win on these projects. Mostly, I like to share some observations from our site. usually we got very good feedbacks as the earlier speaker mentions about the benefits in detail. So we don't have the different experiences. So I think all the experiences are similar to all the countries. The good thing is that our technical teams they find this very useful, not only to explore the BGP anomalies, but also that forward and reverse routing path identifications. So that tools is very promising for day-to-day troubleshooting purpose as well. And besides that, we also started to receive feedback from our internet service providers. So they are also started to use this platform for their troubleshooting as well. So this is the another important area might be we need to look at how we can incorporate commercial sectors in these platforms, or yeah, that might be the another discussion. I think Lawson will update on that perspectives. But from Android sides, so this is one of the important tools regarding these BGP activities. Yeah, over to you.
Thank you, Rajan. First of all, I would like to thank you, Tsinghua University, for this wonderful project. And we got a chance to observe. Can you listen now? Yeah. We get a chance to observe the showcase in China also, in next gen in internet conference. We're so happy that it was showcased over there. Yeah. And in the case of Nepal Research and Education, it's a very small network. NRAN doesn't provide public internet. It's only for academic internet. We have only one ASN. And we have 4 prefixes on V4 and 1 prefix on V6 currently. Yeah, it's connected. Definitely, as Rajan said, it has been very useful for the visibility to our engineers while they are monitoring. They can see how our networks appears to the outside world. Earlier, you have to type in and see those things visually shown, and it's easier to present to others also. Then unexpected routing changes can be spotted because our network is so small, and our NRAN users, academic users, they are not so literate. I don't know when they change something and suddenly something happens. Earlier, it was so tedious to find out the problem. Now with this BGPWatch, it has been very easier. It's visually, you can spot it, but it changes and those things. And that's a better efficiency to our engineers. Yeah, they can decide immediately, clear external data. No, we are not showing data. Yeah. Not showing. Yeah, just speaking. Yeah, I'm just reading for that. And it was very faster for root cause analysis. I think Rajan has already mentioned for that. And as NRAN is a secretariat, and we are looking after NPIX, Internet Exchange Point also. And we try to connect some of the tested with some of the ISP. They are so happy. And they want to connect to our main network also, BGPWatch also. But whether it's possible or not, we have to think over it. And my proposal is, why don't we present this community, internet community, like in July, we are organizing South Asia Network Operators Group. In South Asia, there's a network operator group, which was initiated from Nepal. Now it's in the South Asian operate. Every year they meet. They have a workshop, seminars. It's happening in July this month. Why don't Shinwa group or BGPWatch group make a virtual presentation, or we can invite you to visit Nepal to present them and showcase this case, and can be expanded. That's my proposal to you. And definitely, as I had experience to observe the research work your team has done while we were in China, even gave the presentation of the thesis research papers. We're so excited. I think if you want some more expertise or some more researchers from Nepal side also, we are ready to find some people in Nepal academia also. That will be helpful. Thank you.
Thank you for sharing. We will look for more collaborations between our project partners. Let's welcome the next speaker, Asida.
So my name is Asta Mandaranaika. I'm from Lanka Education and Research Network, and so great to be here. And thank you so much for inviting me to present here. So just a quick background about Learn. We are, of course, the NREN for Sri Lanka. We were established in 1989, so long ago. 37 years ago, actually. And it was a project at that time, and we pioneered the bringing internet to Sri Lanka as well. In 2009, we were established as a company limited by guarantee. So it's a private company, but it's run by the UGC and the state university system. Where our board of governance, board of directors is from all the state universities. We have 64 members at the moment, with 18 full members, state universities and the UGC, and the rest from private universities, research institutes, ministries, and so on. Sorry about that. Yeah, so mainly we are working as an ISP, of course, providing internet connectivity as well as connectivity to the Research and Education Network. We are licensed by the TRC, the Telecom Regulation Commission, and we are providing internet and connectivity through our main telecom providers to SLT, Mobitel, and Dialog to our members. We have coverage throughout the country, especially in Colombo and Kandy main cities, but the rest of the things as well. We are connected to the rest of the world through Singarain or Singapore, in Kane in India. And also we are connected to the Google Cache nodes and Lankan government network and so on. Yeah, that's kind of the connectivity map in Sri Lanka, and also we are connected to the Asia Connect project, TAIN network to the rest of the world. Right. And we also provide a lot of services as more than ISPs, naturally, as most and RENs. All this edu, edu, and we also have video conference in Zoom, and so many other things. In addition to that, we also provide a lot of capacity building and programs and so on. So that's about Learn, a really quick introduction, just for anybody who has no idea or didn't know what Learn was. So BGPWatch project, and we are very grateful and thankful to Senate and Singapore University for getting us as part of this project. So this is, I have to say, this is, even though I'm officially involved as the CTO, mainly this work is done by our senior network engineer, Lalantar, and these slides are prepared by him. So I might not even know some of the things that are there in this one, because he's the one who's involved in this one. I'm just reading out the slides, okay. Right, so we got involved from APAN50, and we have attended, all the scheduled progress reviews and the other meetings and so on. And also, right, so first major involvements was, yes, at APAN 55. Actually, I also attended that one. That was my first APAN meeting, physically attending, and it's a good experience. My first experience with APAN, and it was great to be there and experience this. And also we went to Cernet and Tsinghua. We had a DNSSEC and BGPWatch training program and workshop and sessions at Tsinghua University, which was really enjoyable. Some photos from that as well. Right. So one of the things about BGPWatch project, I mean, I was also really interested because I'm of course by my profession I'm a network engineer, even though I'm now a lecturer or a professor in the university and also working as a CTO of Learn. But my main profession is network engineering. My research topics are network engineering. So I was extremely interested in this project to get involved. But unfortunately, with my other work, I had really had time to really look at the details and get involved. I wish I had time, but I couldn't. So our involvement was kind of limited to providing the necessary support to the Xinhua team for their data gathering and the connectivity and so on. I hope we have provided sufficient support for them to do this testing. It has also given up some insights about these things because something like BGPWatch is not something that is of very much concern to a country like ours. It should be, but we are not some entities that are worth of messing with anyways. So nobody cares about Sri Lanka, learn, and not so far yet, right? So I mean that's obvious from the data as well, which is interestingly, right? But it's something that it has given something for us to at least take note of, right? So that's experience with this BGPWatch platform is very interesting because these are, from my perspective, when I have discussions with our engineers about their experience with BGPWatch platform, what I get is, yeah, this is there. These features are there. We are not really bothered about this, but the things are there, and they like to, sorry about this. Right, so I'm not going to teach you about BGPWatch platform because people here are very much aware of the BGPWatch platform more than me, right? So, but the important thing is that as I mentioned earlier, with our experience, we didn't find any anomalies in our network anomaly related to the Learn network. The AS 38229, but some of the related local ISP actually we found few things which has I mean, if you're knowledgeable, I'm not going to explain these things. I'm just going to just give the brief, big picture view, right? So there are things that we can see, but those are not anything related to Learn. Right, so but few of the ISPs in Sri Lanka or we are related to, there are certain things, not very major scale ones, but when it comes to Learn, there's nothing. That, as I said, we don't seem to be any interest to anybody, right? So, but this is the interesting part about this one is I don't think that even our network engineers are yet really worried or bothered about this. Because we are not being affected, though we are not being targeted, though we are not somewhere in the middle of anything, right? But this has given some overview for them what to be worried about, and I would, one of the things that I would like to do with the BGPWatch, the continuation or extension, is to provide this to probably at least to do some simulations and all that to do these kind of things. So for us, I mean, at least we will come up with some what do you call these fire drills, so that we can see whether our engineers are at least aware of or cognizant and alert to these things. Because I mean, this is a great platform. This is a great things to have, but I don't think that our engineers understand the importance of this. They have not realized the importance of, because we have yet to be have any particular issues. But I know, whenever, like, this, as it happened for the Learn office 2 months ago, when we had floods and we got flooded and our offices got decimated, it's it's no point worrying about it after the fact. So one of the things that we can, if in the BGPWatch project, if you can come up with some fire drills so that we try to make these things target, say, learn network and certain networks, so that suddenly, without informing our engineers, you do something, see whether they recognize these things. If you can do something like that one, I think that will be worth, because we have been kind of asking them how we can use it, what's the thing, but it's still not a problem, so they're not worried. But I am worried because we don't know when it's going to happen, and by the time it happens, we know it might be too late. So something to just to think about, right? Whether we can have some kind of like unannounced fire drills to keep our engineers alert. Okay. Yeah. So that's again, I know it's a common trend. These are a lot of slides here, but I'm not going to take your time just going through each slide. It's the same pattern everywhere. We are not really seeing any major concerns with Learn Network so far with this data. But some statistics with the related networks that we are connected to, because we are connected with our ISPs in Sri Lanka. I don't think, when I ask, these dashboards are there. These are not continuously monitored by our engineers as well. That is my worry. Right? Because having this kind of a platform, once again, it's very beneficial, but we are not really taking use of it because it still has not affected us. So that's I think. Let me see whether I have anything else. Yeah, I mean, it's the same story. I don't want to go into the details of these things. Monitoring everything is, we are aware of what can be done, but we are not really taking much use of it. I hope that our contribution or our participation in the project has been beneficial to the project, and we also had a very good workshops and training programs taking part in this, and we appreciate that as well. But I'm also looking forward to how we can participate in a better way, and also take use of this very advanced platform that now we have developed over the years. It's good to see, because when I got involved very early, and at that time, you can remember how we were trying to get these things done, and it's really good work that has been done. So how can we get involved much better? What can we do? Because from my point of view, I mean, as a CTO, I don't have time to sit down and do this. Right, but we need to figure out. I need to figure out how we can support better, and how also we can benefit better from this one. As of now, it's mostly based on the engineers who are getting involved. If they are not interested, we are not getting anything back. For now, that is my problem. Right? Yes, I think. That's about it. Yeah, so few of the suggestions from my engineer. Real alerts for peer changes, path changes, etc. are preferred. Currently it receives at a particular time with last 24-hour report. Yeah, we are at a time zone with 30-minute offset. Deal with that, please. Maybe you need to deal with Nepal as well. Yeah, right, Rajan, this is not a problem for you. This time zone with 30 minutes, you have 45 minutes. Yeah. Yeah, they're 45 minutes. Yeah. Yeah. Right. Okay. Yeah, so we provided some suggestions in 2023 as well. Monitoring or alerting system for AS path change to selected destination, API for receiving data to display on partners, customized applications, and visual improvement as well. I think this was suggested last time when we were in, when we came to Sonnet or Tringhua last time. Yeah. Right. So yeah, so that's about from me. Thank you very much once again getting us involved in the project. It's been a pleasure, and hope to get involved and be partner in the future as well. Thanks so much.
My name is Yahya, and I would be presenting on behalf of Mr. Kamran. He's fortunately not able to join a bit late. So first have a brief look at PAN. PAN is the National Research and Education Network of Pakistan. It's the only one in Pakistan, and the purpose of it is to interconnect universities, research institutions, and the data centers across Pakistan. We have 100 gig links of our core, and the access network ranges from 1 gigabits to 10 gigabits connecting with the partner institutes. So we provide high-speed connectivity between the institutions, and also we help them with the capacity building and the knowledge sharing, and to enhance their operational practices as well. So PAN peers externally with AS 45773. We are manners compliant, which is mutually agreed norms for the routing security. And for the global RNA connectivity, we have a 2.5 gigabits per second link with the TAIN or Asia Connect. And then we have for commodity internet 100 gigs of connectivity via 2 submarine providers in Pakistan. And we are also present at 2 IXPs which are in Islamabad and Karachi. And each link with the IXP is of 10 gigs per second. BGP peering, we are also doing with the router collectors for the BGPWatch platform, CGTF, and also for the NSRC global RNE routing report, which Philip Smith and the people at University of Oregon operate. So we would be having a brief overview of ASPA, Autonomous System Path Authorization. So the common type of frequently observed incidents in the global routing are either related to erroneous path origination or erroneous path, which can be either be spoofed one, or it can be a route leak. So if the origination is intentional, we can say that it's a route hijack. And if it's unintentional, it could be due to fat fingering, misconfiguration, or routing bugs in the routing platform. And if we talk about the path hijack, it could be done by a malicious actor intentionally for say doing man in the middle attack, or to perform denial of service attack. And if a customer leaks routes from one of its upstream to another upstream, it could be considered a leak. So if we take a look at the example of misconfiguration first, top left, you can see that AS1 is advertising a prefix P. And we have a malicious AS5, which is also announcing the prefix P, and it's trying to hijack the prefix P. So when this advertisement reaches AS4, it compares the advertisement from AS1, which has the longer path. So naturally, it would select the shorter one, and AS5 is able to successfully attract the traffic or hijack the traffic destined for the prefix P. And on the example on the bottom one, in this case, AS5, instead of originating the prefix P, it claims to be connected with the AS1, and it spoofs the path to AS1. So AS4 in this case also, since it has the shorter path, it directs the traffic towards AS5. So AS5 either black holes the traffic to do a denial of service attack, or does a man in the middle attack to manipulate the traffic. And on the example on the right side, we have two ASs, AS1 and AS2. They are peers, and AS3 is a common customer of both peers. And what AS3 is doing is that it's learning the routes from AS1, and all of the routes which is, or a subset of the routes which is it has learned from AS1, it is advertising to AS2. So naturally, or the convention is that customer routes are usually the most preferred ones. So in this case, the routes from AS3 would be preferred, and traffic would be directed towards a suboptimal path. So it can either create a degraded experience for the users or whose traffic is transiting through AS3, or it can also cause an outage. So for the misoriginated part, we have we have route in validation, and in this framework, RPKI is used, and the trust anchors are the regional internet registries (RIRs), and for this region we have APNIC. And what is done is that the originating AS for each of the prefix, it creates a ROA, or route or origin authorization record, in the RPKI database. And it specifies three pieces of information: the origin AS, the prefix being advertised, and the max length of the prefix that is acceptable. So max length is there so that a specific route hijack could not be performed by a malicious actor. So all of the ASs implementing ROV, they would use this information. They would use the ROAs to check the received advertisement and verify if it's legitimate or not. So we have an example for this. AS1, it is originating a prefix P, and it has also created a ROA in the RPKI database specifying the prefix, its length, and the origin. And if a malicious AS5 tries to originate this prefix, AS4, if it is performing route origin validation, it compares the advertisement from AS5 to information from the RPKI database, and it can see that AS1 is legitimate originator of this prefix, so it rejects the advertisement from AS5. So in this manner, route origin validation can help with the misorigination or prefix hijacks. But it still doesn't say if the path is spoofed by AS5 and it claims that AS1 is the originator, but I am the route to AS1. ROV doesn't say mitigate this problem. So for this, it is advertising to the next AS, it signature, and the next AS does the same. It takes the advertisement as it is, and it specifies the next hop in the advertisement and signs it, adds its signature as well. So in this manner, all of the ASs in the past do this.
Yeah, we lost your screen. Your
Okay.
screen. Yeah.
Let me share it again. Yeah, is it visible now?
No.
No.
Oh, it's coming.
Yeah. So I guess there's a connectivity issue. So I was saying that BGP addresses the spoofed path problem. So each AS, what it does is that it specifies the next hop it is advertising the route to, and adds its signature to the advertisement.
See the screen.
Yeah, we still can't see your screen.
It's fine. You can continue.
Yeah. So it's visible now.
Now working.
Not working. Just a moment. There is some issue. Yeah. Is it visible now?
No.
Okay. Let me rejoin the meeting.
Oh,
Maybe.
yeah, we can the screen.
Yeah. So is it visible now?
It is visible right now.
Yeah. Yeah, so I was talking about the spoofed paths, and BGPsec is able to mitigate it by adding a cryptographic signature to it and specifying the next hop of the advertisement as well. So each pair in the AS path, we can verify if the information or the advertisement was legitimately advertised or not. So BGPsec uses BGPsec path attribute instead of the normal AS path. So because the normal AS path does not carry the cryptographic information, so a new attribute is used, and this property or this characteristic is also a weakness of BGPsec because all of the routers in the internet are not speaking BGPsec. So if a BGP-sec speaker needs to talk with the non-BGP-sec speaker, it converts the BGP-sec path attribute into the normal AS path attribute, which doesn't have the cryptographic security information. So all of the information is lost. And for to have any meaningful mitigation, we need to have support of all of the routers on the internet, and we cannot have incremental deployment. We need to have support from all of the routers on the internet, and we cannot do so because there's no such thing as flag day back like there was on in earlier days of the internet. So this is not very effective for mitigation currently. And also this BGP-sec does not address the routing leak problem because the path is still valid from the protocol's perspective. So for addressing the routing leak problem, we have AS path authorization, and it's a work in progress in IETF. And the main idea behind it is the concept of valet-free routing. And the path shouldn't have any sort of valet, and each of the receiving routers of the advertisement can examine the AS path and simply ask that the AS relations in this AS path, do they make sense or not? If they don't make sense, it can declare the ASPA to be invalid, and the route can either be rejected or depreferred, just like we do in ROV, RPKI ROV. So if we translate the rule of valet-free routing into advertisement or AS path, the rule says that the route received from customer or a peer must only have customer to provider peers in the path. So if we take this example, uh, just a moment. Yeah. So if we take a look at this example, AS2 is a customer of AS3, and the route that is advertising only contain customer to provider pair. So this is a valid advertisement. And AS3 and AS4, they are both peers, and the route AS3 is advertising only contains customer to provider peers. So this is a valid case of ASPA. And if we take this bottom example, we can see that AS2 and AS4, they are providers of customer AS3. AS3 is the customer of both AS2 and AS4. Now, when AS3 is leaking this route from here, it contains not only C2P pair, but also P2C. So based on our rule, we can only have C2P pairs from an advertisement of the customer or the peer. So this fails the value-free routing concept or the rule we have specified. So AS4 can reject the update, and even if AS4 doesn't reject and propagates its onward, AS5 can still analyze the path and see that there exists a P2C in the advertisement where it shouldn't be. So it rejects the path. So some more example path trajectories we can have. This is if we take example of this, AS3 is a customer of AS4. So AS3 is also paired with AS2. So the rule says that any route from the customer should contain only C2P pairs. But in this case, we have provider to provider pair as well. So this is also a violation of the value-free routing rule. So it also get rejected. And in this example, if we see AS3 and AS4 are peers, and AS3 and AS2 are also peers. And when AS3 is advertising the route, it contains C2P pair, but also provider to provider pair. So this is also a violation of the value-free routing rule. So this advertisement is also violating the AS path. ASPA rule. So in the bottom, there are valid examples of the AS path. In this case, since AS3 is provider of AS4, it can have C2P pairs, and also if it propagates onward, AS4 is provider of AS5, it can also have P2C pairs, because the rule only applies to advertisements from the customer side or from the advertisement from the peer. So it can only have C2P pairs. So this ensures that only valid and no advertisement, and there are no routing leaks propagated. So how do we ensure, or what is the source of truth for this information, that which customer has which provider? And for this information, we can leverage the RPKI. So in the RPKI, we record the information. Each customer AS is associated with the provider it has. So let's say AS1, it has a provider of AS2. This information is recorded in the RPKI, and AS2 is also has a provider of AS3. This information is also recorded, and AS6 has two providers, AS3 and AS4. This information is also recorded, and AS5 has a provider of AS4. This information is also recorded. So if we have a routing leak, AS6 propagates the routes from this upstream to its another upstream, we can use this information to verify if the advertisement should be accepted or not. So let's say this information reaches AS5. It considers this path AS path 463. The advertisement is this follows this path. So it knows that AS6 has AS3 and AS4 as provider. So 4 to 6 is provider to customer, but the 6 to 3 is an up, customer to provider. So this forms a valley, and in this manner AS5 can reject the advertisement and ensure that routing leak is not it does not accept the routing leak. And if even if AS4 propagates it onward, AS5 can still analyze the path and use this information from RPKI to ensure that leaked routes are not propagated and accepted and propagated further. So so in summary, for path hijacks, prefix hijacks, misoriginations, we have RPKI. For path spoofing, we have BGPSec, but it cannot be deployed widely, not feasible solution. So path spoofing is still an open challenge on which research needs to be done for a feasible solution that can be deployed incrementally. And for route leaks, we have a mechanism for ASPA, although it's still a work in progress, and IETF, but it hopefully would get to a standard or RFC status. So it would. They have also have some implementations. So hopefully it would be widely deployed like RPKI, ROV as well. So this is from my side. Thank you so much.
Thank you. Thank you so much for the sharing. Is Waka's here? If you want, please feel free to add anything that
Yes, I'm here. I would just like to thank you for being part of the BGPWatch project, and thank you, Yaya, for a wonderful presentation. And if anyone of the participants have any query on the presentation just given, please share your queries.
if anyone have any questions. Okay, so if no other questions, I think we will conclude this session for now. So we appreciate everyone to join our session, the two training and also the sharing sessions today. We learned a lot from our partners, and we especially from their sharing experience and perspectives, so that we can know where to improve. Also, we can develop better for the platform and contribute to the community. So we will continue to do more improvements and engagement for the community. We have gifts for the speakers for this session. Please come in to the